Okay, we're going to start working with strings a little bit more significantly than we have, because there's actually a lot you can do with them. Strings are not a primitive data type, so strings are abstract data types. So that means they have data plus actions, which are referred to as methods. So in this one, oh my gosh, that's the wrong terminology. This program called string methods is going to show all of the different methods that strings can perform. So C++ is functions similar to methods here. So what we're going to do is we're going to start by declaring a string variable. So string my text. We'll just use it for a bunch of whatever. Now, in this program, I would encourage you to write down the comments as they come up, because this will be a really good reference for you to come back and test strings out to try to figure out, like, okay, well, what do I need for this program that I'm creating? So we're going to start by having the user enter a piece of text. So my text equals, my text, let's put the prompt here correctly. System.out.print, and we'll just say enter some text. That's it. And then the way that we read it in is my text gets the value of input dot. Now there's different next line. So next line tends to not care what the user has typed in. It's just going to take it and then enter it here. Because in all of these instances, I mean, we're going to be getting text in there. This one's pretty good. There's other ways of programming where you use next line for integers and then put it into a string and then turn it into an integer just to make sure that you're getting the right input. So string methods. Let's take a look at what we can do with this. So the first thing that we're going to do is system.out.println. Now, what we're going to do is write the method in quotation marks so that we can see it in the output. So I'm going to pick char at 3. So what we're going to get is this is how we apply it, my text dot. So we use dot notation to indicate that whatever we write here is a method that is going to affect, and it belongs to my text. And then we're going to put in char at 3. And then we'll put this here. So let's see what happens. I'm going to run my program. And I'm just going to write the word hello. And then char at 3 gives me an L. Now I'm going to maybe write it with something a little bit different here. So I'm going to write in alphabet. Okay, so we get an H. So let's take a count. First, second, third, fourth. So H is the 4th character, but it is in position 3. So here's how it works, is strings are stored 0, 1, 2, 3. So the first address in any string is position 0. So let's put a little bit of notation here. So char at x returns a char type character at position x. Now, it's important to know what kind of information these are returning. This one is not actually generating a string, it's generating a single character. So that's an important distinction here. And also, the first position of a string is 0. Now another thing that happens here is I'm going to run this. And here is a common error. I'm going to put in hi. And you're going to get this thing. String index out of bound exception. So here's the problem, is I have a string with only positions 0 and 1, and I'm asking my program to look at position 3, which doesn't exist. Every time you get that, you're going to get this. Sometimes you're going to be looking for a number that is further than the end. Sometimes you'll accidentally put in a negative based on like a complicated loop. So that's how you can identify that you've gone outside of the string. Okay, moving on. System.out.println. This one is going to be instead of char at, we're going to try and find where something exists. So we're going to find the index of O. And the way this is going to work is we're going to put in my text dot index of, and then we're looking for a string here. So this receives a string type variable. And I'm going to run this again, and we'll see what we get. And I'm going to type in hello. So our index of O gives us that the O is in position 4. So 0, 1, 2, 3, 4. Yeah, that checks out. Now I'm going to put something slightly different here. I'll do a little copy and paste. Now what I want to do is I want to find the index of the double L and see what it generates. So I'm going to run this. And I'll type in hello again. And so O is in position 4. Double L is in position 2. So let's see how that works. 0, 1, 2. So what happens is it finds the first index where this string begins. So if I was looking for LLO, it would also be 2 because that is the starting position of that string. So now what happens if I put in, I'm going to run this, and I'm going to put in octopus. So there are 2 O's, and notice there are no double L's. What is it going to do? Okay, so it gave me a 0. So index of gives you the first position that it shows up. It'll ignore any position after that. And then the double L does not exist. Whenever it can't find it, it returns a -1. And this is very important. We can use this information for lots of things. So whenever it doesn't exist in the string, index of returns a -1. So let's put a little bit of information about that. So index of, and I'll put returns the first position of the search string. So the search string is in here, and we get the position that it exists within the root string. And then it returns a -1 if not present. Now, if you wanted, we could do another one called last index of. And let's keep this as O and look at octopus. So last index of. So if I run this, Sometimes you will have a program where you need to come in from the end instead of the beginning of a string. So if I put in octopus again, my first index of O is 0. My last index of O is 3. So sometimes this is a useful one if you have to come in from the opposite direction. Now, what we're going to do is we'll do system.out.println, and this is going to be a replace all. Now, this is going to require a couple things. This is going to require, let's say, a letter. So I'm going to keep going with the octopus hello example. And we're going to replace everywhere that there's an O, we are going to put in for no particular reason. So here's what that's going to look like. I'll do a little copy paste here. So my text dot replace all, and we're going to replace all of the O's with ooh. So if I'm running this then, what is my error here? My text dot, oh, this isn't all caps. Wonder how that happened. Okay, we'll run that again. Okay, so I'm going to put in a hello. Okay, so then we get our result here. And then I'll run that again, and I will put in octopus. So you can see every time that there's an O, it replaces every instance with the new string. There's also a replace first. So if we do a replace first, it'll only replace the first O. Octopus. There we go. So you can see the difference between these two. All right. Now, a very important one here, and this is length. And you'll see that length contains no arguments inside the parentheses here. And it shows up like this. So what this is going to do is returns an integer value with the number of characters. So I'm going to put in octopus here, and octopus has a length of 7. Now there's something that's very important here, is you have to be careful with length. Imagine I wanted to use length in order to print the last character, like using a charAt. Don't program this. So this is an extra example using charAt. But instead of 3, what if I wanted to use this to get the last character? And I'm going to run that. And octopus. Now we get a string index out of bounds exception. So it says string index out of range 7. So with the word octopus, it has 7 characters, but remember that the last position is not 7, it's 6. So if you ever need to use this, you always have to subtract 1 from it. And then it'll work totally fine. hello now gives us the last letter. So this is really useful, but you have to be careful with the length, that the length is not actually the last character. Okay, so now what we're going to do is we're going to go over the most important one. So system.out.println. Now we're going to use substring 2, 5 and see what we get. Okay, so my text dot substring 2, 5. Now, is this going to give me the second character to the fifth character, which should be, or is it going to give me only 3 characters, which is going to be 5 minus 2 is the difference? Let's see what it generates. So I'm going to put in octopus, and here's what I get. Top. So surprisingly, it starts at position 2, which is the T. And think about this. Position 2, 3, 4. So we get 3 positions here, but it does not actually include position 5. So what this does, and this causes a little bit of confusion sometimes, so it returns a string with the characters from position 2 up to, but not 5. So we get 2, 3, and 4, 2 up to 5, but not 5 itself. This is actually a useful thing, because imagine that I wanted to go from 2 to the end, which is, I've always theorized about why it runs this way, and I think it's so that you can do this. I want to go from position 2 all the way up to the end, and as opposed to charat, this actually works totally fine. So what I want to do is I'm going to enter some text. I'm going to put in octopus. Now, this works without crashing the program because it goes up to, but not including the last position based on the length. So that's a pretty handy thing. Now, what we're going to do, the last one, just to round this out, just do a copy and paste so I have to type less. All right, so to uppercase. So my text dot to uppercase, and again this one receives no arguments, and not surprisingly there's also a to lowercase. So I'll run this. I'm going to put in this in the worst possible way. So octopus. So we get an uppercase and a lowercase version, but something interesting happens here. And this is an important thing to know. I'm just going to print out, after we're done all of this work, let's just print out my text and see what we get. So I'm going to put it in this horrible way again. And so now the last step that we have is a to lowercase. Let's see if this is going to be a lowercase result. So you can see that it's not actually changed. So one of the big misconceptions is that if I use some of these methods, it's going to adjust my text. It never does that. What it does is it returns something based on it. So this one returns a string that is an uppercase version of it. This one returns a string that's a lowercase. This returns a string that is like from position 2 to the end. So if I actually want one of these to affect it, here's what I need to do. My text gets the value of my text dot to uppercase. So now it will get replaced by an uppercase version of itself. So if I run this, and I'll put in octopus, there we go. So now what I get is at the end of this, it actually replaces it. So we can solve a whole lot of problems with this this list of string methods, and we're going to be using them in some different combinations in future programs.